I have a lot of content today. I'll take it up as a challenge. But before that, I think I should talk something about myself. So I'm Ishan. I work as a software engineer at HackerRank right now. I'm a final undergraduate, actually just graduating next week, right after this. And I've been giving a lot of talks recently, but this one, I thought React Native was just another talk. But today is a very special day for me, and I'll tell you why. So last year, I got the opportunity to actually attend React India. And I had the privilege to attend this particular talk by some speaker. In case you didn't recognize him, his name is Tejas Kumar. And I was mind blown by the way he delivered his content and every single thing. And then we met and he invited, Tejas invited us to his place. I gave him a little something with a note, and that note read something around, looking forward to seeing you next year. Who knows, maybe I'll be sharing the stage with you. And today is that day. Tejas is also speaking. He's here in the audience, and I'm in that. But talking about things that are special for me, there's another special moment that happened with me when I was 12 years old. I started with Visual, C++, and all that stuff, but it was a bit boring, to be honest. And then when I started with web, it was like love at first sight. For me, the main reason was that it gave me this empty canvas, which I can use to paint something and share it with anyone in the world. And it's just a profound feeling, which is very specific to web, right? And today, we'll be taking that a bit further by diving into immersive experiences. Now, what do I mean by immersive experience? If you talk with someone else, some people refer to AR, VR as immersive experience, which is kind of true. But at least for the sake of this talk, what do I mean by immersive experiences? So I would define it something like this. For me, anything that adds a sense of depth, volume, or scale to the web is an immersive experience. In order to understand this in a better way, we have to do some time travel. I just took this time machine from Doraemon. So let's go back to 1990s. You have these web browsers, Netscape Navigator, or you have NextOS. This is before Steve Jobs returned to Apple. And they had a lot of limitations, in the core sense that these browsers were known to be document viewers. They were meant to be document viewers, and internet was used to just share technical documents or research papers with other people. But then, a lot of other things also happened, but VRML came into the picture in 1994, which was the first sort of thing that allowed developers to go ahead and create something. Then CSS was introduced, then Flash also came into the picture. But in 2011, something magical happened. That is when WebGL was introduced. Now, what's WebGL? It is a JavaScript API which provides some bindings to OpenGL 12.0. In very basic layman terms, it basically allows us JavaScript developers to run a code, some piece of code on a user's CPU. With that, let's dive into 3D. So I have a 3D model of a dolphin here, by the way, my favorite animals. And this particular 3D model, it is made up of skeleton. This is called a mesh. And this mesh consists of a huge number of polygons. The most basic polygon that someone can create, you can notice the triangles over there, is a triangle. This is also called a primitive. Let's see how we can use WebGL to actually go ahead and create this triangle. It's fairly easy to get started with. You just go ahead, start with add a canvas element, then you define some document.query selector, get the canvas context, and then you write this piece of code. Don't worry, it just looks overwhelming. We'll go through this. So it's very easy. You just start by defining some vertices or some indexes for all of these edges, and then you define something called shaders. What are shaders? These are actually, in very layman terms, these are individual programs that run on the GPU. Now, there are two kinds of shaders. One is vertex shaders. The major difference between vertex and fragment shaders is that these help in transforming positions or computing positions, and they run once per vertex in a mesh. For example, for a triangle, it would only run thrice. And then this is the code for that. After that, you have to define something called fragment shaders. These help in painting the objects or actually adding colors. A good example could be, let's say you're defining a gradient between point A and B, then what should be the color between every single pixel between those points? That is something which fragment shaders take care of. But just look at this, right? This is the entire piece of code that we wrote in order to draw one single simple 2D triangle in WebGL. So you can imagine that if you're working with the 3D scene like this, things can get really, really complicated really, really fast. That's why we use some layers of abstraction or some libraries to help ease it down. And one such library is Three.js, which is what we'll be exploring today. Now, I can't wait to jump into the editor and show you some cool stuff. Who's hungry, by the way? I am hungry and I'm craving for donuts at the moment. So this is just a simple example that I created. We just have a 3D model of a donut and that's it. Let's see how we can get started. I just have a sample starter project here. Nothing fancy. All you can do is you can just go to your terminal, do yarn create beat, and then I want you to add 3JS by doing yarn add 3 and then yarn dep to spin it up. So if you just go to this, I just have this index.html which has some basic content, and then I'm just importing this script file, this main.js. Over here, I'm just importing some CSS styles, and that's it, nothing major. So let me go ahead and actually let me remove this content so that we have that blank empty canvas that we wanted. Now we have 3JS, so let's go ahead and import it. I'll do it something like, let's say, hey, import star as 3 from 3. Awesome, but now what to do next? We just have an empty canvas. In order to understand that, I want you to think of yourself as a film director. Imagine you're Christopher Nolan directing Oppenheimer or something. Now at this point, what happens is, let's say you're recording or you're shooting a scene for your upcoming movie. In that case, how do you get started with that? For that, let's say maybe you need an empty canvas or a good frame where you can actually go ahead and record something. This looks a little bit boring, so let's add a few objects, maybe a lighthouse here, maybe a tree house over there. And then we can introduce our actors. This could be a scene where superheroes are chasing a villain or something like that. But now we have the perfect shot ready. Now we need a way to record this. For that, we'll add a camera maybe to capture stuff. And then as a director, I'm not going to go ahead and play around with cameras to that extent. I just want to sit in my chair and look at how the output is looking at. So maybe I'll just put everything on a reference monitor. And if you look at this, the key requirements for this are actually very similar to 3JS. All you need is, you first of all need an empty frame, and then you need some sort of objects, let's say trees, lighthouse, could be actors as well. Then perhaps a camera to capture that stuff, a monitor to render that stuff or to display that stuff. And this was a scene which was, let's say, somewhere in Antarctica, so you don't need light. But in case you're creating this in a studio, maybe you'll add some lights as well to enhance that stuff. Now, actually creating one in 3JS is fairly similar to this one. Let's jump back into our IDE, and let me show you what I mean. So I'm here. First of all, let's go step by step. What we need is an empty canvas. So we'll add a canvas here, literally empty, there's nothing here. Then I go back to my main.js, and let's start by creating a scene. So I'll just do const scene is equal to new 3.scene. Perfect. Now what I need is, I need a donut in this scene, right? So let's start by defining our donut. Donut is equal to new 3. Now what is a donut? It's basically a mesh, right? We need a 3D model. So I do 3.mesh. Well, now what this thing needs is, it needs two things. One is geometry and one is material. Okay, so let's go ahead with that. We'll start by defining geometry. There are multiple sorts of geometry in 3JS. Sphere, it could be a rectangle or anything else. What we need in particular is a torus geometry, which is kind of like donut shape. And this accepts two things. One is again radius, it could be a number, and second thing is cube. So I'll just go with something random. I want a smaller donut. I don't have a lot of appetite at the moment. And then 0.2 maybe. So you have this geometry, you have donut. By the way, I hope the code is readable. I'll just zoom in. And then what we need is, second thing that we need is a material. What should be the flavor, basically, of our donut? So I'll go with, let's say, new 3.mesh standard material. Again, there are different sorts of materials. Let's say if you're wearing a piece of clothing, could be cotton, could be something else as well. And now you can define colors. I can either go ahead and just write red, or in 3JS, a better notation is actually using hexadecimal notation. So I can do something like 0xFF0000, which is again red. Now we have our donut ready. So donut needs geometry and material. Now the most important part, which is something that I forget, or almost miss all the time, which is you have to add it back to the scene. So scene.add donut. Awesome, let me move this here as well. But we still can't see anything. That is because now we have our objects, but we need a way to capture this stuff, right? So we'll start by defining a camera. Now again, in 3JS, there are multiple sorts of cameras. There's orthogonal camera, there's perspective camera. Perspective camera is the one which is closest to a human eye, so let's go with that. By the way, in 3JS, you can have multiple cameras, and with that, basically, you can just use one and instantly move it to a new position because of JavaScript. Now, this needs FOV. So what is FOV? It's called field of view. So when you have a lens, right, there's a field of view of distortion. let's say this is how far I can see, and if I go beyond this, then the view will get distorted, like how wide you can see. So the default is 50, I'll just go with that. Then we need aspect ratio. Let's just calculate on the fly using window.inner width, specific to this particular screen of course, divided by window.inner height. Awesome, we have that. Now next two other problems are, you need near and far. Near is how near you can see, and how far away can I see. So it would be, let's say 0.1 and 1000. Now we have it, let's add it to the scene, but we still can't see anything. Why is that? Because we need a monitor as well. Remember the key requirements. So monitor is basically nothing but a renderer. We'll just do, hey, renderer, new 3.webgl renderer, and this needs a canvas. We already have a canvas. I'll just pull that, document.querySelector canvas. Now we can just go ahead and render this. So we can just say, hey renderer, can you render this and take the scene and the camera. Now we do see this, can you see this little small black rectangle on the screen? Let's increase the size. I can just do a render.setSize, window.inner width, window.inner height. Awesome, but we still can't see anything. Now why is that happening? Not to understand better in a better way, we need to talk about Cartesian coordinate system in 3JS. Don't worry, it's not going to be a boring maths lecture, but basically the Cartesian coordinate system, it indicates that when you have an object at the origin, let's say in this case it's a donut, and you have three axes from that. One is you have this x-axis which always goes in the horizontal plane, and you have a y-axis which is always in the positive y plane, and then you have a z-axis which is in 3JS by convention pointing towards you, because I'm going to be pointing towards stages right now. And then what is happening right now is that we have our ring here, we have our donut here, but it's not actually showing up. The reason for that is our camera is actually also at the origin. So it's somewhere inside this donut. That's why you can't see anything. So what we have to do is basically somehow we need to move this camera on the z-axis or along some other axis in order to actually capture it. And how can you do that? In order to do that, we can take advantage of something called transformations. Basically, we can use these three coordinates, these x, y, z coordinates, to apply any sort of transformations. The most basic ones are position, rotation, and scale. Position could be, you can just define the position, whether I'm here, whether I'm there on stage. Rotation, you can do this on any other axis. Let's say you can rotate anyone around one particular axis. Right now I'm rotating or spinning around y-axis, but you can do that, and scale as well. Let's jump back into our IDE and let's apply what we learned. So I'll go back and we have our camera. I'll just move the camera position. Camera.position.z is equal to, let's say, 3. We still can't see anything. The problem is that the one that we saw in Christopher Nolan movie, that was a real one, and this is an artificial environment. So we need to add some sort of light. Again, in 3JS you have different lights, and I'll be going with the very basic one, which is a point light. Let's make it white. Let's use that same notation that we learned about, and we have to add it to the scene, scene.add light. Now we can finally see something. Let me move the light to here in front. So light.position.z is equal to, let's say, 3. Awesome, we can see your donut. And actually, there's another cool part, which is if I go ahead, if I set wireframe to true, you'll notice that this entire mesh was built by those polygons that we just talked about in the beginning. Now, this doesn't look like a donut, right? So let's actually do that. Let's convert this into a donut. So for that, we need, let's say, hey, chocolate flavor. That sounds fancy. Now I'm actually hungry, but basically this is a technique called texture mapping, where you take some 2D pixels. Over here I have this folder where I have this image of a donut. There's the base and this is the top. Now what you can do is, this is actually strawberry flavor. So let me change that, strawberry. Perfect. And hey, berry, double R, my bad. 3.texture loader, you can just use that. And we can load our texture, which is donut.png. Now we can apply that texture map using this map property and then texture. Oh, strawberry flavor, sorry. And now you can see actually it looks gray. Our image is not there. So what's happening is that texture load is actually an asynchronous function. So before the render thing after the render thing happens, after that it actually loads the texture. One easy hacky way to fix that is that, hey, you can just do set timeout. And let's just say, hey, after 500 milliseconds, you can go ahead and render this. And I can see our texture is there. But this is actually a hacky way. So better way to do that is actually we can take advantage of something called request animation frame. This basically accepts a callback. I'll just call it recursively. This particular method, this is a browser API, it accepts a callback. It will call it before entering the next frame. I can just call this here. Let me call the animate method. And you can see our donut is here. Now we can go ahead and apply one of the transformations as well. I can just do, hey, donut.rotation.z plus equals 0.001, I don't know. And you can see our donut is spinning. Super cool. Let me bring back the content to actually get done with this. Now we have a content here, but in the real one you can see our donut is actually somewhere over here and it's rotated around a particular axis. So let's apply some transformations, what we just talked about. I'll go ahead with this. Let's say donut.position.y. First of all, let's say 1. Now this 1 is positive y-axis, so maybe how about something like minus 0.6. That worked. And then I can do donut.rotation.y is equal to minus 0.75, and perhaps donut.position or rotation actually should be rotation dot x is equal to minus 0.75. Done. With that we have a donut. I'm actually craving for one right now, but this was just a quick glimpse of some of the limitless possibilities of Three.js and cool stuff that you can build with it. You can build donuts, you can build spaceships, you can build Earth, whatever you want. I look forward to seeing whatever you will create. And in case you want to take a look at the source code, you can just scan the QR code of this GitHub repository. With that, we have reached the end, and we're almost on time, on 15 minutes. So thank you. In case you have any questions or anything, please feel free to connect with me in the launch, and I'll go ahead and grab a donut now. Enjoy the rest of the evening. Bye everyone.